Good morning, students. In the previous class, we studied about reflection of light, the types of images, basically the real image, virtual image, how to differentiate. And in today's class, we are going to study about the image formed by a plane mirror and how it is. And the second one is certain important terms in the case of a spherical mirror. In the previous class, we studied about two types of spherical mirror, concave and a convex mirror. And the next one is certain rules for obtaining images with the concave and the convex mirror. So, two things are with the spherical mirror and one is with the plane mirror. This is our today's topic. Can you see this image? Which is an object, which is an image? If the letters are not written, we can't identify. That much both are appearing exactly the same one. Actually, one is object, another one is image. It is marked clearly. There is a plane mirror in between them. Because the plane mirror produce exactly the same size of the image. Now, if you see here, this is what in your life every day it's happening. You may stand in front of a mirror and do whatever. So that only we are going to study today's class. Images, how it is formed with the help of a plane mirror. Now see in this diagram, this is an object. The object may be anything. It may be a candle flame, torchlight, or you, or your pencil, or any object. You keep your cell phone. So, how the image is formed? The image is formed on the other side, and the black color line what is drawn here, it is the representation of a plane mirror. Now the light from the object goes and falls on the mirror and gets reflected. The light from the object, the green color light, falls on the mirror and gets reflected. Now if you see here in this diagram, these two are the incident light, these two are the reflected light. And if you see the reflected light, both are diverging. Then how to get the image? So this is another diagram which tells about how the image is formed. Here the object is a cake. And the other side I get the cake of the same size. And this is normally the way of representing a plane mirror. A line. This side of this one is the polished surface, and this lines what we have drawn just like a shade like that is a unpolished or a rough surface. We get the image. Actually this is the thing which tells about how the image formation takes place with the help of a plane mirror. Now see here in this diagram, the object is moving. Depends on the movement of the object, the image changes the position. Now see, object moves up and see image also moves up. Object comes down, the image also comes down. As the object moves closer, image also. Whatever object does, same manner, image also moves. Now if you see in this diagram, from the object we have taken two rays. Can you see here? Two rays are there. From the object, minimum two rays are enough. And how as the object changes the position, the reflected ray also changes. Now a candle is the object, the blue color one is the incident light, and we get two reflected lights. But the reflected light here, these two are diverged rays. But basically we know our human eye always perceives the rays of light only in a straight line path. So, the diverged rays will never meet at a point. So, in order to get the image, you produce both the diverged rays in the backward direction. This is geometrically we are drawing. Nobody is there to produce it, pull it or anything. So, what is happening here? It is, see the same diagram, this is the object. These two reflected rays are diverged. So to get the image, produce it. Now if you observe this line, it's a single straight line. And if you observe this, it will also be a straight line only. It should not bend at any cost. So what is happening here? It is incident light, reflected light. Reflected light is diverged one, but all the things we are producing it, the reflected rays we are producing it. If the reflected ray actually meets, I will get a real image. The reflected rays are produced back to get the image, then what I am getting, it is a virtual image. Now if you see the object and the image, object and image both are of the same size. See the diagram, you can make out. So what are the properties? Basically, the size of the object and the size of the image remains the same. Generally, when you stand in front of the mirror, plain mirror, your face will not be big or small. It is the same size. And one more thing is, if the object is, how much is the distance between the object and the mirror, same distance will be maintained between the mirror and the image. Suppose if I move the bottle close by, the image, in that case, the image also comes close by. So that is the second character. Tomorrow or today itself, you can take any object and you can experiment this by standing in front of a mirror. Now see here, so I can say the images produced by a plane mirror is virtual. Now the person is standing. So this is the object and this is the image. What is the object size? Image size remains the same. Object is standing, image is also standing. Same manner. See here, here object is standing, here image is also same size, same vertical, erect, and the size is maintained. But one more thing, if you see, in this case the person is bringing his right hand to give shaken to anyone. But if you see this person, don't look at the object, only look at the image. This, if we see, it appears as if the person wants to shake hand with his left hand. So the right appears as left and the left appears as a right in this case. So generally, what are the properties of the image formed by a plane mirror is? They are virtual, erect, same size, distance is same. What is laterally inverted? That is one word. Laterally inverted. See, in this diagram, if you take it, one is the object, another one is the image. If I consider this the object and the next one is image, in the object, his right hand is shown. But if you see the image, his left hand is seen. See, stand in front of a mirror, do anything with your right hand. In the image, it appears as if it is done with the help of a left hand. Left is changed into right and the right is changed into left. That is called as lateral inversion. So these are the same things. See here in this diagram, a person is lifting his left hand, but the image, if you see, it appears as a right hand. So the left changes into right and the right changes into left, but not top and bottom. This character is called lateral inversion, interchanging of left and right side of the thing. See the letter, it is written. You can write English alphabets and keep it in front of the mirror and see how it is changes. See in this diagram, somebody is playing, a person, a player, he is holding a ball in his hand. He is holding a ball in his right hand. But you see the image, in the image it appears as if he is holding it in the left hand. His left leg is touching the ground. But if you see here, in the image it appears as if his right leg is touching the ground. So the left appears right, right appears left. This is the way the right left interchange. This is only called as lateral inversion. So these are some of the characters of the image formed by, characteristics of the image formed by a plane mirror. This is lateral inversion. See here, he is raising his right hand and on the other side image it is the left hand. See, this is the thing. You can check it at home. This is the one more reason why the letter ambulance is in the ambulance always written in the reverse way. You write and check, you will get enjoyed. You have sufficient time now. Everybody's house mirror is there, and any letter you write and check how the mirror image is formed. Now the next one is we should know what are the important terms in the case of a spherical mirror. This is a mirror. Which mirror? Concave or convex? Yes, it is a concave mirror. There is a point here, the center point of the mirror, that is called a pole. And we have already studied the word C, center of curvature, because the mirror is derived from a sphere. So the point C is called center of curvature and the point F is called the focus. And already we saw the distance between pole to center is called radius, pole to focus is called focal length, and a line if I drawn between pole to center, that line is called the principal axis. And the whole surface here, wherever light falls, the light gets reflected. This is a reflecting surface. That is called by another name called aperture. So these are the important minimum things you should know about a mirror. There's all these points we have already discussed. So that is for a concave mirror. This is for a convex mirror. Convex mirror, it is on the right side, and concave mirror, it is on the left side it is formed. So now you see, what is this point? Focus. What is the distance between pole and focus? Focal length. What is the distance between pole and center of curvature? Radius. And this is the rough surface and this is the polished surface. The reflective surface is called the aperture, and this is for a convex surface. And all the things whatever I said, it is given in the form of a definition. So how, if they are asking what do you mean by a pole, right? That way if they ask, just to go through this one. So the focus of a concave mirror and the focus of a convex mirror, all the definitions are given here. So here, what is this mirror? Concave mirror. Parallel rays are falling after reflection. All the rays are converging to the point. This point is called a focus. Both the slides we studied last class itself. So the point where the image is converged, that point is called focus, and the distance is called focal length. Concave mirror converges, but a convex mirror diverges. The diverged rays will not meet, so in order to get the image, I produce the rays back. All are meeting at this point. So I am producing it back. So what type of image it forms? Virtual image. Actually they meet, so it is a real image. So these are the things about concave mirror and convex mirror. All these terms you should know. Now the last part of today's class is rules for obtaining images. The image formed by a spherical mirror. So there are two types of mirror, concave and convex. Let us start with the concave mirror. The first one is, this is what mirror? Concave mirror. So what are all the important parts? Pole, focus, center of curvature. Now, if you take here, I have taken my first ray as this one. This is my first ray. My first ray, this is called the incident ray. Is it parallel to the principal axis? This is called the principal axis. The incident ray and the principal axis the principal axis both are parallel. So the first rule is, if the incident ray is parallel to the, I'm sorry children, if the incident ray is parallel to the principal axis, after it falls on the mirror, it gets reflected. The reflected ray always passes through the focus. Can you see here? It passes through the focus. But this is applicable only if the incident ray is parallel to the principal axis. See, this is the incident ray. And see, this is the principal axis. The black color and the blue color line both are parallel. So you may ask, can I draw the incident ray like this? Yes. Now this red color line is parallel to principal axis. After reflection, this ray will pass through the focus like this. This is the incident ray, this is the reflected ray. This way it passes. So it's not necessary I have to draw only by this way. I can draw like this also, it passes. Clear? Now, so are you clear about the first part? Incident ray parallel to principal axis, reflected ray passes through the focus. This is for a concave mirror. So what will be for a convex mirror? So the first ray I have taken here, the first ray, it is this one. Can you see here? This is the incident ray. The ray after falls on a mirror reflected back. It's a convex mirror, so it's a divergent rays. The ray comes. Only one ray is enough. So what is happening is it goes like this. From where it comes, if I study, it appears as if the ray is coming like this. From the focus as if it is coming like that. If you observe the reflected ray, as if it comes from the focus, it appears. So, if the incident ray is parallel to principal axis, both the diagram, this diagram and this diagram, incident ray is parallel to principal axis. But here reflected ray passes through focus, here the reflected ray appears to pass through the focus. This is rule number 1. The rule number 2 is, suppose the incident ray passes through the focus. What will happen? Just the reverse of that. See, the incident ray passes through the focus, reflected ray is parallel to principal axis. Just the reverse of the previous one. Parallel to principal axis, passes through focus, and here passes through focus, parallel after reflection, it is parallel to the principal axis. So what will happen for a convex mirror? So this will happen for the convex mirror. Incident ray, if I allow, it will go to focus. But because of the mirror, it cannot pass through. But after reflection, if I observe, this is parallel to the principal axis. Children, if you observe this diagram and the previous slide diagram, both appears the same, only an arrow differs. Arrow says which is the incident ray, which is the reflected ray. This is rule number 2. What is the rule number 3 is the ray which is passing through center of curvature. If a ray of light falls on the mirror through the center of curvature, it is the normal incidence. This is the normal, this is the incident ray. So normal and incident ray remains the same. What is the angle of incidence? 0. If angle of incidence is 0, angle of reflection also 0. So the reflected ray will go like this. Incident ray and the reflected ray both are same. It retraces its path. It comes as an incident ray and goes back as the reflected ray. So only one single line is enough. Same thing for a convex mirror. But what will happen? It comes up to this. Afterwards, if I produce, it passes through the focus, center of curvature, and it comes. This particular rule is very useful for you to draw the ray diagrams later. So please understand, any line which passes through the center of curvature, it goes straight and comes back. There is no need to draw the second one. See the same one. And the last one is obeying the laws of reflection. Obliquely means it makes certain angle with the principal axis. Now you see, this is the incident ray. It falls on the mirror at pole, and this is the reflected ray. Here I can check the angle of incidence and angle of reflection by that method. And it falls on the pole. Same thing, but here it will not come on the other side. So there are 4 rules we have studied. Quickly, if we recall, first rule, incident ray parallel to principal axis, reflected ray passes through the focus. Can you see? Incident ray, reflected ray. The same thing in reverse way, incident ray passes through focus, reflected ray parallel to the principal axis. These two are exactly the same idea, just the reverse of that. The third one is the ray of light passing through center of curvature retraces its path. There is no change in the path, same thing. And this is oblique incidence, I is equivalent to R. But children, remember, Question one, first rule, the second, third, everywhere I is equal to R is applicable only. So now if you see this single diagram, you will get almost all the ideas I have used. See, can you see here? There is a ray. That is not working. Okay. See, this is the ray parallel to principal axis. The reflected ray passes through the focus. Second one, you see, this is the object. Incident ray passes through the focus. Reflected ray is parallel to principal axis. Third one is, it passes through the center of curvature. Same thing, retraces its path. So this is one simple example. We will see many more things later. So this is the way the ray goes. So in today's class, we have studied first about image formed by a plane mirror and its characteristics. Then we studied about certain important terms in the case of a spherical mirror. What are the important terms? Pole, focus, center of curvature, radius of curvature, focal length, aperture, focus of a concave mirror and focus of a convex mirror. Then 4 rules we have studied for a image formation. These rules we will use how to get the image in the case of a mirror. Are you clear, children? Please go through and I'll send the assignment questions. Write the answers and send it to me. Thank you.